Yeah, hello. Today we're going to be looking at binomial theorem. Right, let's get started with that. Firstly, what is a binomial? A binomial is a polynomial with two terms. So, for example, if you have x to the power of 3 plus y to the power of 2. This is an example of a binomial. Another example of a binomial could be 5y to the power of 2 plus 2 plus 2 to the power of plus 2. This is a binomial. So a binomial is a polynomial of two terms, right? Now, what is the binomial theorem? The binomial theorem basically is this: that it's possible to expand. So if we have x plus y to the power of n, the theorem basically says it's possible to expand this to give you a to ax to the power of b, y to the power of c. Alright, so it's possible to expand it to give this, where b plus c is equal to n. So b and c are the exponents. B and c are the exponents, and obviously this mainly works for positive integers. So b and c are the exponents, and a is the binomial coefficient. So the binomial theorem again states it's possible to expand x plus y. So x plus y, covered bracket closed, raised to power n. It's possible to expand that to give you a x to the power of b, y to the power of c, where b plus c is equal to n, and a is the binomial coefficient. All right. Now, there are a few things that we need to two things you should know about exponents before we go full detail into the theory. All right. Right. First thing, anything to the power of 0 is equal to 1. So x to the power of 0 is equal to 1. 1000 to the power of 0 is equal to 1. 1 million, or whatever number to the power of 0 is equal to 1. Infinity to the power of 0 is equal to 1. So anything to the power of 0 is equal to 1. And if we have 2 to the power of 2 is equals to 2 times 2, obviously. Right? And 8 to the power of 4 is equals to 8 times 8 times 8 times 8. Alright? So it's good to have those basics covered up. Okay? So in the same way, x plus y raised to power 0 is equals to 1. In the same way. Alright? Now, x plus y raised to power 1 is equals to x plus y. The same thing. Alright? Now notice this. So if we have x plus y raised to power 2, this is the same thing as x. So okay, we're going to have x plus y, alright, which is the same thing as x squared plus 2xy plus y squared is equal to this. Alright? Now, So let me write that again. So that's x squared plus 2xy plus y squared. Now, if you look at this, from here, if we write the coefficient here is 1, 2, and 1. So the binomial coefficient, if we're doing that, 1, 2, and 1. The exponent here is 2. So we have the exponent of 1 plus y plus 1, which is 2, and here 2. Alright, so notice the exponent always combine to y. So if we go back to the binomial theorem where we said for x plus y raised to power n would always give us a x b y c, where b plus c is equals to n, right? So if we so taking this back to x plus y raised to power 2, so we have x is 2x squared plus y squared, right? So here, using our binomial theorem, so if we compare it to what we have in our binomial theorem, we have the a here is 1, y is to the power of 0, obviously, because anything to the power of 0 is 1, so y is to the power of 0 here, so the exponent is 2, the coefficient here, so a here is 2, the component, the exponents here are 1 and 1, and that's 2 as well, and the exponent here is 2, while the coefficient is 1. Alright, now let's try that. So I just want you to notice this 1, 2, 1, right? So now let's try that for x. Let's try that for x plus y raised to the power of 3. Now obviously this will be the same thing as this. Alright? Now this is going to give us, if you work that out, this will give you this. Alright? This is what it will give you. So it will give you x to the power of 3, 3x squared y, 3x y to the power of 2, and y to the power of 3. Now, again, comparing this to a binomial theorem, so I'm just going to put our binomial at the top. I'm going to put our binomial here, so we'll have it as, so we can always compare it. A x to the b and y to c. So that's our binomial there. So if you see a here is 1, while the exponent is 3. So it always adds up to 3. Always adds up to give you 3. The exponent here is 3. Always adds up, and both 2 plus 1, they add up to give you 3. Here is the exponent here is 3. 2 plus 1, they always add up to give you 3. Here as well, the exponent is 1, adding up to give you 3. Right? Now, the one thing we'll notice here, so if I get rid of this, the one thing you'll notice here, the first one we had 1. So when we did, yeah, so when we did the x to 1, we got, so when we did x plus y raised to power 1, what we got was x plus y, which the coefficient is 1, and here the coefficient is 1. Now, all right, let's and when we did x, we did x was 2, we got our exponents, our coefficients as 1, 2, 2, 1. Now these things look very similar to Pascal's triangle. All right, so let me give you Pascal's triangle now. Now this is Pascal's triangle. We start with the 1, 1, 1, 1, 2, 2, 1, 1, 3. One, two, one. Oh. Sorry. Yeah, so that's 1, 2, 1. The next level will be 1, 3, 3, 1. You see, it all matches up with the Pascal's triangle. So in Pascal's triangle, what you do is that you add the two terms directly above combine to give the term underneath. Right? So we start with the 1. So the next here is obviously, as we have at the bottom, 1, 3. So 1 plus 2 will add to give 3, 2 plus 1 will add to give 3, and you have 1. Alright? So so let's make it bigger. 1, 2, 1. 1, 3, 3, 1. 1, 4. 3 plus 3, 6. 3 plus 1, 4, 1. 1, 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1. And it goes on. 1 plus 6. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 1 plus 5, 6, 1. So it goes on like that and like that and like that. So this gives us the coefficients we have in our binomial theorem. So let's, for example, if we're asked to do x plus y to the power of 5, okay, right? If we wanted to do x plus y raised to power 5, well, these are coefficients there, you see. So our coefficients will be, starting with the first term, it will be x to the power of 5 plus 5x to the power of 4 y plus 10 x to the power of 3 y squared plus 10 x to the power of 2 y cubed plus 5 x plus 5x y 4 plus y to the power of 5. Alright, now these are the coefficients. So using Pascal's triangle, we're able to solve and get the solve the polynomial with binomial theorem. Alright, now one other thing that you will notice as well, you will notice as well, is important to notice, is the exponent. So the exponents, the combination of the exponent, as we mentioned at the beginning, b plus c always equals to n. So the exponent of x and y is always 5. So here the here here the exponent is 5. Here the exponent 4 plus 1 is 5. Here 3 plus 2 is 5. 2 plus 3, 5, like that. The exponent is always 5. And now it's always in a particular order. So starting with the first term x, the exponent decreases and gets to 0. So here, let me see. So here, the exponent of x here is actually x to 0. Here, the exponent of y there is actually y to the power of 0, which is equals to 1. This is the same thing, equal to 1. Alright? So it's always equal to 0. So the x term starts from 5, decreases to 0, while the y term, the second term, starts from 0, increases up to 5. And for each stage, the combination is always equals to 5. So this basically shows you how to solve a binomial theorem. Like, so now if we had numbers in there, we'll be able to solve them out and give you a final figure. So let's test out if our theorem works, with real numbers, not with x and y's, or not with unknowns. Let's see if our number works. Let's see if this theorem works with real numbers. So let's use something simple. 2 plus 3 to the power of 2. Alright? Now, our binomial coefficient according to Pascal's triangle is, so we need 2 here, so 1, 2, 1. So this is what we need. We need 1, 2, 1. Alright? Right. Okay, so first thing is going to be 2 to the power of 2. So 3 is 0 there. So 3 to the power of 0 plus the coefficient is 2 here into 2 times 3. So that's 2 to the power of 1, 3 to the power of 1 plus 2 to the power of 0 and 3 to the power of 2. Alright, so this gives us 4. This gives us 12, while this gives us 9. This is equals to 25. Right, another way. So here, if we don't do out a binomial this way, let's just do 2 plus 3 is equals to 5. This is equals to 5 squared, which is equal to 25. Alright, let's get some of this out. So this is equals to 5 squared, and all of us know the square of 5 is 25. Alright, thank you very much. I hope you've learned something, and if you have any questions, just go to the student request section of Ujuzi. So go to the student request section of ujuziafrica.com and send your request in, and we'll get one of our teachers relating to your question, to be able to make a tutorial for you. Thank you very much.